Hi, folks. Thanks to be here for this talk about an experiment in continuous deployment of JVM application. I'm Nicolas Fränkel. I've been a developer. I've been a team lead. Well, I worked 18 years in proper engineering, and since 2 years, I'm a developer advocate. And because I was consultant for a long time, I always had to work in real life projects. And I have a lot of ideas, so being developer advocates allows me to have creative, I wouldn't say crazy, but creative ideas regarding what we can do and what we cannot. I work for a company called Hazelcast. Hazelcast has two products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So instead of having your map and it's inside a single JVM, then you can shard it, replicate it, whatever. And the second is Hazelcast Jet. And since I will be talking a bit more about Hazelcast Jet in the later stages, then I will skip it for now. Right now, I want to focus on an engineering concern. What we call continuous integration. And continuous integration has multiple steps. So depending on the stack, the steps might be a bit different. For example, in compile languages, we have compilation. Like if you use JavaScript, of course, you might not have compilation. But if you use TypeScript, you might have transpilation. Anyway, you have this first step, then you have unit testing. Probably you need to package it somehow. Then you have more tests, integration testing. And perhaps if you are using containers, then you have, again, packaging inside a container, and perhaps some tests that go on this stage. Then you store it in the registry, and you know the drill. And it has been pretty popular for a long time. But now we have a lot of continuous stuff, whatever it is. And continuous integration is mentioned. We know it for a long time, and I believe that every company should implement continuous integration in one form or another. Perhaps you don't have containers, then it's fine, but then the process of compiling and testing in an automated way should be standard. It should be the golden standard everywhere. And now we have a new term, this CI/CD. You see it conflated in a lot of places, in blog posts, in podcasts, everywhere. And the problem is that it makes it the same, but those are very different concerns. The fact is, first, CD doesn't mean anything because it can reference either continuous delivery or continuous deployment. And then even the difference is that continuous delivery, you make the package ready to be deployed in your production environment, whereas continuous deployment, it is deployed. So in continuous delivery, you still have a manual action just before the deployment, whereas in continuous deployment, everything has been automated from the Git commit to the deployment. And then continuous delivery is much harder because you need to think about the architecture. You need to think about what your infrastructure is like. Again, as I mentioned, whether you use containers or not. And it's so wide a problem that it's very hard to do, and not a lot of companies actually do it. And if you do continuous deployments, like Facebook, like Google, like those big companies that can not allow themselves to have downtime, you need to have a no downtime approach. And if you are on the JVM, that's interesting because the traditional JVM deployment model is, you stop the JVM. If you are using a servlet container, then you deploy your new war and you start the JVM again. Or if you are not using a war, you are using a self-executable jar, it's the same. You need to stop the JVM, you overwrite the jar, and then you start the JVM again. And that introduces downtime for sure. So regarding downtime, you might already have read or heard about approaches that allow to have no downtime. The most famous one, the first one actually, was the blue-green deployment. In blue-green deployment, you have two environments that are like mirrors of each other. One is considered the current production environment, so here it's the green one, and the other is, as I mentioned, the complete mirror of the green one, and then you deploy everything on the blue one, and at the push of a button, you switch the router from the green environment to the blue environment. Now the blue environment is your production environment, and the green one, well, you can deploy your next release. Well, of course, I've been an architect, so it's very easy to tell that on a diagram, but it just opens a new can of worms, because there are a couple of issues related to this. The first thing is database. You need to migrate the data from the green environment to the blue environment. If you have millions of records, might not that be visible. So another way to cope with that is to say, okay, the database is common between the green and the blue environment, but then what about if I need to change the database schema? There are a lot of issues regarding that. Another way to do that is if you are using a container orchestration platform such as Kubernetes. Kubernetes allows to do rolling updates. And in that case, well, it's magical. You just say, hey, I deploy like the version 2.0 on one node, and then on another node, and then on the third node. And well, it's the same issue as previously. What about the database? I mean, if you have stateless workloads, it's always easy. Now, as soon as you introduce states, and I believe that most applications, they need somehow to deal with states, it's an issue. So it's not super great in the JVM world and in general. But what if I told you that you could actually change the bytecode inside of a JVM with no downtime? That probably you would call it magic. But in this talk, I will focus on that. I will tell you how you can achieve that. So the first subject I want to touch is the Instrumentation API. That's an API offered by the JVM. And the second is the Attach API. This is also an API offered by the JVM. And then I will bind the two with streaming. And then finally, I hope that I can show you the demo. And of course, I hope that it will work, but it's always a risk regarding demos. Regarding instrumentation, you might have come upon the term like Java agents. I believe that if you are in Ops or in DevOps and you needed to get some metrics about your application, you probably had to configure a Java agent that was provided you with the metric solution. And this Java agent is like a simple jar. It just has inside of it some specific metadata in its manifest. And this allows it to change the bytecode of the running application through the Instrumentation API. You have two kinds of agents. The first one is a static one. And as I mentioned, if you have been dealing with a metric somehow, this is probably what you did. When you started the application, you had to add an additional parameter -Java agent column and pass to an agent jar. And then it starts your application with this Java agent that is loaded as startup. There is another kind that it's much less well-known, and it's a dynamic agents. And in that case, that allows to start your Java application normally, like completely oblivious of any concern, and then to load this agent jar on a running JVM. In order to create an agent, you need two things. First, you need an entry point into the code. So if you know about Java, you know that applications, they require a static void main with like a var args of strings or an array of strings. And here, it's a bit different. The method name is slightly different. Like it's either pre-main for static agents or agent main for dynamic agents. And then you have this additional argument that is parsed for you by the JVM called instrumentation. So that's on the code parts. On the configuration ports, you know about this meta-inf manifest. So in this manifest, you need to have this additional configuration setup. So either for like static agents pre-main class and for dynamic agents agent class. Again, this is just mirroring what you would need to have in a regular self-executable jar, which is the main class. This is required because the JVM needs to know which entry points it needs to call. Instrumentation has actually two different use cases. The first one is to change a class that is already loaded in the JVM. Of course, there are limitations. And the other is when it loads a class, it can apply an automatic transformation of the bytecodes. This is the instrumentation API from a bird's eye view, but it is much more than enough for our purpose. So this is the instrumentation interface that will be passed into our pre-main class or agent main. And you can do several stuff. You can, as I mentioned, add transformers that won't be used. You can, and that will be used, do something called redefine class. And it accepts a var org of class definition. And the class definition is as simple as a class and a byte array. And the byte array represents the bytecode that we want to like override the already loaded class with. So that's on the agent side. And now we have the attach API. And as I mentioned, the attach API allows to load an agent like inside another running JVM. And the like what is really amazing is in general, when you want to reload classes inside your JVM, you use class loader magic, or you need to run in debug. And when you are running in your IDE, you just like compile again and your class will be reloaded. Here, the JVM just needs to load normally. There is no requirement. There are other requirements, but they are on the system side from the attacher. They need to run on the same system. And the attacher JVM must know the PID of the attached or the would-be attached JVM. And this is, the API is even simpler than the previous one. Basically, you have like two packages. The first one, you have like two classes. The first one is the virtual machine, and the virtual machine provides a static method that accepts the ID of the PID and returns a virtual machine, or more importantly, probably an implementation of the virtual machine. And if you are using hotspot, for example, a hotspot JVM, then you've got this load method that allows you to pass the path to the agent plus options if the need be. And that's all. Now we need an option to move the bytecode around. So there are different ways to do that. We can do batching. So like regularly at scheduled interval, we'll check that something changed, or streaming. And because compilation could be an ever-ending process, then we'd probably use streaming, because streaming is made for infinite stream of events. And there are different in-memory stream processing engines. So some of them are based on the clouds, just as Amazon Kinesis or Google PubSub, and some are based on premise, so Flink, Jet, or Beam. And you can choose, of course, the one you want. But because I'm working for Hazelcast, I will just describe Hazelcast Jet. Actually, Jet is available under a friendly Apache 2 license. So everything that I will show you is not only open source, is also free. You can use it as a single jar inside your application. That's what we will be doing. There is another deployment model where we have a dedicated Jet cluster, but I won't touch it into this talk. And if you start from batching, if you have never used streaming, then you can create your pipeline through like a batch mindset process. And then just by adding one line of code, you can make it to a streaming API, meaning that you will always be like handling events, and it will be an infinite stream of events. This is Hazelcast Jet from a bird's eye view. And as I mean, every other stream processing engine works the same, but here is just an implementation. You have like sources of data, you have sinks to which you want to write your data, and in between you have your stream processing engine that probably like Jet is distributed, and you can enrich your streams, you can like do some operations on your stream, you can do some analytics by aggregating or whatever. And finally, this is my overall design. This is what I want to achieve. So I have my normal application here that runs in a production JVM. And this application doesn't know anything yet about IMDG or about anything. The only thing that it has is an attach API because it's running on the JVM. And by default, the attach API is a capability of the JVM. As a second step, what I will do is I will start a new streaming JVM that will run this Jet job, and it will read from a folder. And in my demo, it will be a folder on my local computer. And this folder is the target of my compilation. This is where all my class files will be. So if there is a change, Jet will like watch this folder, and as soon as there is a change, it will stream the results into this IMDG. And in that case, I'm using a hash map, and I will store entries, and the key will be the class name, the fully qualified class name, and the value will be the bytecode as a byte array. And the third step is to start this new injection JVM that whose sole purpose is to inject this agent jar that I have prepared into the production JVM. And this agent jar will make this app that was completely oblivious to what happened here, like be aware of it. And then as soon as there is a change, it will subscribe to the map. And as soon as there is a change, it will redefine the class that is running. So that was the static view. Perhaps it's easier to see the flow. So I have this production JVM already running. I start my Jet job that's like loop over and check that the source classes has been changed or not. If it has been changed, then I will put the bytecode into the Hazelcast IMAP. And then I will start the injection JVM that will attach itself to the production JVM. And because of the agents that I mentioned before, then now my app will subscribe to change events from the map. And so as soon as there is a change, it will read the value and it will reload the bytecodes. And perhaps I've talked enough now. Now it is time to show the code. So let me close everything. And here is my initial application. This is a simple web application. I'm using Tomcat embedded, and I'm creating a very, very fine piece of engineering. And what I'm doing is I've created a servlet, and this servlet is served through a Tomcat embedded. So if I start it, you probably can like wonder what it does is it prints hello world. Amazing. Now I'm really a good developer. That's the first step. Now I will close everything. That's what's supposed to run in production. Now I have this source stuff. And once what I want is I want to change that source, which is in another project, which is not served by Tomcat. And I want to like, if I change my source, it needs to be written into a class file, which Javac will do. And then I want that class file to be streamed to the running JVM. And for that, the second step is actually to start the jet job. So this is the jet job. And what it does is it will actually like read from the targets, and just if there is a change, it will put it into the buffer. And it's up to Jet to take the buffer and to put it in IMDG, as you can see it here. So I will just like read from the target folder, and I will write to the cache, to the IMDG. And before, I want to check that nothing has changed. If nothing has changed, I don't push the bytecode, because it would be stupid to reload the class if there was no change. So that's the second step. And now the jet job is running, and you can see it's running and it does nothing. And the final step is to attach an agent to the production JVM. Now it's taking a bit of my resources, of course, because I'm running on my home computer. And now I run this. And it will, as I mentioned, it will inject the agents into the production JVM. And now, as you can see, my production JVM now has become aware of jets and is actually listening to the changes. And the final step is just go into my source servlet. So this is the servlet that is in the source. In the work, that's my production load. And here I will say big data. And I just need to compile it. And normally here, I should see, hello, big data. Whoop, it's been done. I will switch off everything because I showed that it worked. And I can show you that the attach application is actually pretty stupid. Like, this is what it does. It loads the agents, and when it has finished loading the agent, it detaches itself. So it runs and stops. And as I mentioned, I need to pass the PID of the running process. And well, because I don't want to check the PID of the running process every time, because every time it changes, what I'm doing is I'm using the process handle and to get all processes and just to find the ones that actually have this class, that contains this class name, and then I get their PID. And that's all. So of course, you will tell me that there are some limitations. Of course, there are many limitations. It's not supposed to be a full-fledged project or product. It's just a demo. So the first one is not really a limitation, is you have no version tagging. Like, if you don't do continuous delivery or continuous deployment, basically what you are used to is you create a version of your application, you tag it, and then you store it and you deploy it. And that's the usual stuff that you do. But if you do like perhaps 10 deployments per hour, it quickly becomes impossible to do this kind of stuff. So it's not really a limitation. It's more like it's a paradigm shift. A true limitation in this demo, of course, is I don't load any new classes. I'm just having a class that runs perfectly well, and I just change its implementation, one of its implementation method. So if you want to write new classes, I don't handle it in this demo. I cannot deploy new classes to production. Finally, the redefined classes is pretty limited in itself. You cannot add or remove or rename fields or methods. You can obviously not change the signature of methods. You cannot change inheritance hierarchy, and those are pretty hard limitations. So there are some improvements. Of course, in the real world, you wouldn't stream for your computer. You would stream from your continuous integration pipeline. And that's what could be an improvement. So you would just run your continuous integration pipeline. And at the end, you could not perhaps stream, but perhaps batch, like push, force those changed bytecodes to your production JVM. If you want to know where your changes come from, then perhaps you could add additional metadata through a class transformer that is part of the instrumentation API. And in order to overcome the limitations that I mentioned, the fact that you cannot add or remove fields or methods, blah, 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 then you could have different class loaders, and you could just kill a class loader and load this incompatible class into a new class loader. And if you know about Spring DevTools, that's exactly what they do. Of course, it's a lot more engineering work, but I believe that this is the path to what could be achieved like this. So thanks a lot for your attention. You can follow my blog. You can follow me on Twitter. You can check the Hazelcast website. More importantly, if you are interested in what I showed you, if you want to go deeper, if you want to find, to improve and perhaps make a PR, then the code repository is on GitHub. It's available. You can read it. You can clone it. You can do whatever you want with it. And if I interested you in Hazelcast Jets and streaming in general, you can join our Slack channel. That's the main point of his presentation, is once you see that streaming is just the processing of unbounded streams of events, you can apply it to a lot more use cases than you would have thought beforehand. In general, you use stream processing for big data, you use stream processing for analytics, and that's all. But actually, shifting your mindset from batches of events, of separated events, to an infinite stream of events, you can find really, really crazy use cases for it. And I hope that, this is one idea among many. I hope that this presentation open your mind to this kind of stuff. So thanks a lot for your attention, and I will check Slido now if you have questions. So you have no questions. It's always a bit awkward when there are no questions, because I don't know if it was because it was a very good talk and very clear, or it was a very bad talk and you don't dare shame me about what I did. In all cases, if you don't have questions, so I will count to 5. 1, 2, 3, 4, 5. Okay, if you are too shy to write your questions, I will just join the session afterwards, and you can ask more questions privately. So thanks a lot for your attention, and be sure to join me tomorrow morning for an introduction to stream processing. Thanks a lot, and have a good rest of the conference.